What's going on, ladies and gents, folks? I hope you're all doing well. Mr. D'Souza here. I'm going to create, hopefully, a quick video that reviews the last two lessons. Unfortunately, there's a bunch of you I have not seen because, especially my fourth grade class, I miss you all very much because I literally have not seen you for like the past week. Some of you have been doing amazing stuff with NHS. So I know some of you have been missing class. So I thought, you know what? Why don't I just make a review video of these two lessons that we did this week? So we're going to do a quick review. I'll have examples for everything because, as I've said, you're going to have an exam test. I don't want to call it an exam or test. It should be very short on the second half of this coming week, so Wednesday or Thursday. So let's hop into it. Series review by me. Let me stop being corny. All right, so let's review. A series is the sum of the terms in a sequence. So remember, a sequence is a list of numbers in a particular order. So for example, 2, 4, 8, 16, 32 is a geometric sequence, right? Because to get to the next term, you're multiplying by a common ratio. But a series is really if you were to sum these numbers. So 2 plus 4 plus 8 plus 16, so on and so forth. So we learned a couple of things. First thing that we learned was, well, what if I wanted to sum a certain amount of terms in a series? This is typically called a partial sum because it's summing a part of a series. Typically, series go on forever, right? Pattern, if you already know that like the common ratio is like 5, you can just continuously multiply by 5 to get to the next term, right? But if we want to know the sum of part of a series, you can use the formula below, where A represents your first term, R represents your common ratio, and K represents the number of terms that you want to sum. Typically, this letter you can see in textbooks are written differently. Sometimes it's N, K, I. It could be a bunch of different things. But in essence, you just need 3 things to sum a certain amount of terms in a series. So why don't we just do a quick little example? If I said, hey, find the partial sum of the first 10 terms of this series. So what I could do is the following. I like to write out my formula, A times R to the K minus 1, all divided by R minus 1. Where A is my first term, I can see that my first term is a fourth. My common ratio, I'm going to say that for last because usually that's the more annoying thing to find. And K is the number of terms that I want to sum. Well, I want to sum 10 terms. It's going to be in the directions, 10. Now, again, we are only really learning about summing geometric series. I have mentioned this in class that we learned about summing arithmetic series. That was similar to Gauss's formula. We actually did that almost on day 1. So to find the common ratio, right, we can see that this is geometric, right? If not, we can test it. We know that if to get to the next term, you multiply by the same thing each time, that means it's geometric. So there are 2 ways to do this. One, just go to Desmos, divide 2/12 by 1/4. What do you get? Then divide 4/36 by 2/12. See what you get. If you get the same number, it's most likely going to be a geometric series. Okay. For me, what I like to do is, especially if you have fractions, this is one of the reasons why I love fractions so much, is I figure out on the top, how do I get to my next term? How do I get to my next term? So 1 times 2 is 2. 2 times 2 is 4. 4 times 2 is 8. So the top is being multiplied by 2 each time. To get to the next one on the bottom, 4 times 3. Let's see. 4 times 3 is 12. 12 times 3 is 36. And 36 times 108. 36 times 3 is 108. So my common ratio is 2/3. All right. So now we can do the work. So 1/4 times my common ratio, which is 2/3, to the K power, which is 10 minus 1, all divided by my common ratio, which is 2/3 minus 1. This is what I will tell you. You're going to put this on Desmos exactly the way it is. So I encourage you, pause the video, see if you get the same thing that I get. And if not, definitely when we come back to class, please ask. You should know how to use Desmos. You should know how to structure and format on Desmos. We've been doing it since September. So if you are having issues, please let me know. So meet me back here in like a couple of seconds. All right, so I hope you try this on your own. Again, do not write it as a decimal number. Do not write it as a decimal number, because what's going to happen is you're all are going to round. Rounding is not an exact answer. If the question does not tell you to round, don't round. So I got the following: 58,025, all divided by 78732. That is my answer. All right, so the second thing that we did is, here's another example. I'm going to set this one up for you, and I'm going to have you solve the rest of this problem. So you might be looking at this and saying, this is not the same thing. It is, right? Because we already know that a geometric series, right, is A1 times R to the K minus 1, right? Like this generates the terms of a geometric sequence, right? And this tells us to sum the geometric sequence to make it a series, right? So we already know a lot of this information, right? We already know that this is A, like this is our first term. This is our common ratio. And then this is how many terms, right? The number of terms. So if our formula is the following, all you need to do is substitute it in the formula, right? So we know our A is 1/2. We know that R is 4. Our K, the number of terms, is 8 because it tells us here. So to the 8th power, oops, I made a slight error. So 4 to the K power is 8 minus 1, all divided by R, which is 4, minus 1. That's it. And again, what you would get is the following. And you should get something along the following. So 21,845 over 2. Again, no decimals. All right, so the second thing that we learned for this week was the wild thing about summing an infinite amount of terms in a geometric series. Now, we learned that you can, but kind of. So you can sum an infinite amount of terms in a geometric series if, and only if, that your common ratio is in between the numbers -1 and 1. Long story short, when you have a number in between -1 and 1, it kind of restricts basically how much your series can grow over time. If you're more interested about that, please reach out to me. I'd be more than happy to explain it or even show you some other cool stuff about series if you're interested. Now, if this is true, if our common ratio is between -1 and 1, then we can say that our geometric series will converge. Converge means it adds to a number. You must be like, what? How's that possible? Trust me. So if your common ratio is in between -1 and 1, we say it converges, and we use the following formula to determine that. Crazy how this formula is smaller than the last one, yet it sums an infinite amount of numbers, which is crazy. Now, if R is not in between -1 and 1, then we say that our series diverges, meaning that it sums to either positive or negative infinity, meaning it's not countable. For example, 1 plus 2 plus 3 plus 4 plus 5 plus 6, so on and so forth. Well, that's infinity, right? Think about it. You're adding one more to each number. Of course, it's going to be infinity. Same thing if I did like 2 plus 4 plus 8 plus 16. Like that's going to be infinity because it's getting bigger and bigger and bigger and bigger. So let's do some examples. All right. So this is typically how it would be written out formally. Let's just do it. So determine if the following converges or diverges. If it converges, determine what value the series converges to. If not, state that it diverges. So again, I'm going to go quickly backwards. If it converges, we're going to use this formula, a divided by 1 minus r. So a divided by 1 minus r. Now, first things first, we look at this and you might be like, whoa, this actually kind of looks a little bit weird. We're starting with the number 0, we're going towards infinity, and what happened to that n minus 1? It doesn't necessarily look like a geometric series. So first things first, let's figure it out if this is a geometric series. So a very quick way to do this is just by substituting in the numbers. So for example, okay, now let's just figure out the answers to all of these. Okay, so it definitely looks like it is increasing by a multiple of a number. So let's see. Again, what you could do is you can take any two terms that are next to each other, divide them, and see if that is the common ratio. That's probably the easiest way to do this. Or just look at the numerator and the denominator. The numerator seems to be being multiplied by 3 each time. 1 times 3 is 3. 3 times 3 is 9. 9 times 3 is 27. So the common ratio, it's going to be 3 on the top. And then in the denominator, it's not increasing at all. So it's being multiplied by 1. So 2 times 1 is 2. 2 times 1 is 2, etc. 3 divided by 1 is 3. This series diverges because the common ratio is not between -1 and 1. That's it, and that would be the answer. Let's do another one. Okay, so again, determine if the following converges or diverges. If it converges, blah, 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 basically figure it out. If it diverges, just state that it diverges, right? So again, let's go back. Our formula is a divided by 1 minus r. So I'm just going to write that on the side just so I have it here. A 1 minus r. So let's figure out the common ratio. Again, I like to use this trick all the time. Feel free to divide any two consecutive terms. You'll get your answer very fast. But we want to make sure that this is geometric. If it's not geometric, like this formula is not going to work. Okay, so you can see that for the numerators, it's just being multiplied by 1. Multiply by 1, multiply by 1 each time. Oops, I don't know why I wrote it like that. So my ratio is going to be 1 divided by, well, 2 times what is 6? Well, 2 times 3 is 6. 6 times 3 is 18. 18 times 3 is 54. So let's assume that the common ratio is 1/3. Check it out yourself if you didn't do it already. 1/3 is in between -1 and 1. Therefore, we can actually sum this infinite series. If these numbers went on and on forever, according to what we're talking about, we can actually add it all up. So let's do it. Take a second, put this on Desmos. If we don't get the same thing, that means you did something wrong. So please, if you need help knowing how to insert like fractions with fractions, whatever it may be on Desmos, please let me know. Okay, putting it as a decimal, that's not precise. You got to be precise. Okay, so you wind up getting 0.75, which is the same thing as 3/4. So summing this series infinitely, you would get 3/4. So that's all I got for you. We learned how to sum partial series, and we also learned how to sum infinite series. If it's an infinite series, if your common ratio is between -1 and 1, you can use this formula, a divided by 1 minus r, to get what it converges to. If your common ratio is not in between -1 and 1, well, it diverges, meaning that if you were to sum up all the terms, your terms would approach infinity, meaning like the biggest of big numbers, right? It's the idea of going on forever, or negative infinity, the smallest of smalls. Anyways, I hope you all have a great day. I hope this was helpful. Again, please study for your test, quest, quiz, whatever you want to call it, and enjoy your weekend. Bye, everyone.